starting to work on
the associate dean of the Leeds Beckett University, Andrew Platten, to deliver the 1 hour lectures, the guest lectures for us, right? The topic today is the environmental assessment, right? So we welcome Andrew. Thank you very much.
Thank you. Thanks for allowing me to speak to you all this evening. We are obviously in Hong Kong, and it's great to have an opportunity to meet all of our students from time to time. For me personally, as you may be aware, we obviously franchised the Building Services degree to you here in Hong Kong, and actually some time ago I decided to teach the module low carbon buildings. So the high workload, the difficult exam questions, and the very wide subject area is all my fault. So I do apologise before I start, okay? So me and Alan work together. This is the third time I think we've operated the module now. So every time we learn something, because this subject is changing as we speak. It's changing all the time. And it's becoming very, very critical to the world of building services and the provision of buildings. So it's a very interesting subject to engage in. So as Alan's indicated, this is about next week actually, so a little bit ahead, but it was easy enough for me to present. And we'll talk about environmental assessments and also something called the SBEM, which may be of use to you. Now we have 1 hour, and there's quite a bit of content which is involved in this. But effectively, the treatment, we're considering the treatment of non-domestic buildings, including BREEAM, and you see that we do include LEED, and you'll see in the notes consideration of the US LEED system, of which there is a relationship. Now, because of the time limitation, that may mean that Alan will deal with that next week, but it is within these slides. And also, we have a calculation methodology, SBEM, which is an introduction. Okay, there are some comparisons. This is taken from a paper, actually, a research paper, which makes comparisons between some of the common assessment methods. And what's interesting about this, it also includes Hong Kong BEAM. So you can see that there are a lot of assessment systems being used worldwide. In fact, the original performance comes from the Building Research Establishment Environmental Assessment Methodology, and a long time ago the LEED system was actually derived from BREEAM. And obviously there are local systems, there's a Hong Kong system, but there's also systems within Malaysia, Singapore, mainland China, Australia, Dubai. So all the time there are various systems which are about. So for building services engineers and for architects, designers, specifiers, they're increasingly faced by different forms of assessment. And they all do slightly different things. It may be considered, and a later slide will show it, that there is some flexibility in the LEED, but it features particular, there's a specific feature on energy and the cost budget, a financial approach to energy needs, with some flexibility in there. For BREEAM, that is feature specific, so you'll find within the BREEAM code, and I'm going to take you through that, a lot of different features, but they look at performance level assessment. Okay? For Hong Kong BEAM, it's again performance based and feature specific. So the scope, if we just look across on these, energy efficient design, annual energy cost. BREEAM looks in particular at annual CO2 emissions. So it's trying to figure how environmentally sensitive, or let's say, how environmentally aware the building is. So it looks at CO2 emissions and energy efficient design. Actually, that approach is very particular, because if you were to go back a few weeks in your lectures to Kyoto, you'll know that there was a monitoring of every nation, every signatory nation to the Kyoto Protocol, offers up its CO2 emissions annually. UK is part of the European Union, so all the EU countries add their emissions together, and the EU makes one submission into the Kyoto Protocol. The US didn't sign it and did not submit CO2 emission data, but what's been very significant is that at the Paris Earth Summit, those emissions were finally submitted. So they've come in line. Actually, most of the nations now have realised they must do this. It's absolutely critical. So at this year's summit, the issue is avoiding 2 degrees of climate warming. And we've got to do that. And actually, if you were to calculate what it means now in 2015 to meet the 2050 assurances, we can't burn any more of the fossil fuel in the earth. So this is only the starting point to measure your CO2 emissions, and then you have to do all the other things to reduce. So BREEAM originally is there so we can actually measure CO2 emissions from a building. And then there are lots of things in the BREEAM system to ensure that the design is energy efficient, so we can actually bring down those CO2 emissions. HKBEAM has a number of other facets within that. It looks at annual energy usage, so watts of energy, maximum electricity demand, energy efficient design, and the performance of the building envelope. So there are criteria on the materials used. You may look at this and compare and see how these are brought out, because they are actually covered in each of the standards to a lesser or greater extent. In terms of performance, LEED focuses in on a reduction of 60% of annual energy cost over a budget. BREEAM goes to the goal of 0 emissions. That may sound very much idealised, but actually many of our buildings have to go beyond 0 emissions to reach that 2050 horizon. In the UK, we should be going to 0 emissions for new buildings in 2016. They've allowed that to be extended, so now we're looking at 2018, 2019 to go towards 0 emissions. So that means new buildings are 0 emission led. That's very, very taxing for a non-domestic building. Even for a domestic building to get 0 emissions is a high thing. But we think we might be able to do that with some of our buildings now in place. You can compare that to a reduction in 57% of annual energy use over a baseline case study for the Hong Kong standard. These things do change all the time, so this is a little bit dated actually. There are minimum credit level performance, baselines, minimum requirements. This is very interesting. This one here under BREEAM, which is 160 kilograms of CO2 per square metre per year, and that consideration as being the minimum credited performance. So anything over that emission level is actually out. Compare that to BEAM, which looks at kilowatts of energy per square metre per year. It's very similar, but one of the considerations is the type of fuel that you use. So we could have 2 buildings which have the same energy usage, and I admit for a building services engineer that's quite a tangible figure. But if you achieve your kilowatts using gas, you can have so much CO2 emitted. If you switch that to electricity and go to coal, it's higher. And you can do the same using wind turbines, it's free energy, and it's lower. So obviously, if the key thing why we do this is to limit climate change, actually it's about CO2. I'm not saying these are easier, that's a more tangible thing, but we have to think about CO2. Okay? Now there are different levels of energy rated credits in all of these schemes, and that's one of the considerations. BREEAM can be seen to be very wide, as we'll see. and you can get confused with a lot of different facets, okay? So when we balance the two big ones, the US and BREEAM together, some systems can be quite simple in approach and they give the architect flexibility, which is good, but BEAM can be seen as more academic in its approach and more rigorous because it's looking at trying to capture this CO2 and measure it. So those are the differences. It's not surprising that actually in the US there are other standards around which are very, very strict on how they operate. And so if you're reading and wanting to be very, innovative in your approach, you could look at the Living Building Challenge. You come across that Living Building Challenge. I've got a note there at the back. Yeah?
Yeah.
All right. Are you using that here?
No, it's because in 2003, two of my colleagues joined that expo.
Yeah.
And they took, and after that they come back to office and have some presentation to
Ah, very good.
And I know that it's more rigorous compared with the LEED and also the AIBE.
Absolutely.
It's totally zero.
We have we are facilitating Living Building Challenge in the UK. So, as you know, it's divided into different areas, petals. So we convene a petal meeting with Leeds Beckett University on an annual basis. They will meet on Wednesday in Leeds because we're focusing on water usage. So anybody who's interested in water, if you can't get to Leeds on Wednesday evening, you may want to go online to our Green Vision website because we're actually having a CPD event on water usage and how we achieve the standard. So it's interesting. But yeah, there are other approaches. So we have lots of tools in front of us. Key thing is to know what you're measuring actually, okay? Now obviously BREEAM does have relevance in UK to our energy policies and our regulations, but actually you can find that this reference from Meta Gulkasi, LEED can actually work alongside as part of a global basis. So one of the things is when you get involved in BREEAM and it is used internationally, sometimes you're focusing on UK policies which are quite strict in themselves, but sometimes global policy means that this is more internationalised in its approach, and LEED is used throughout throughout the world and common out here. So there are different considerations. In the lecture, we look at the two. But let's think about BREEAM first of all. And there are different systems, but for multi-residential buildings, BREEAM, like most of its other forms, is a two-stage system. First of all, it's a design control, and from design you get an interim certificate, and then you complete the building and you get a final certification at the point of completion when some of the final checks can be made. Actually, there are critics in the UK who say that actually at the point of handover of the building is not the end of the matter. It's how you use the building afterwards, which is where Living Building Challenge comes in. But also some of the other systems, for example, the German Passive House looks at how you use the building. And actually sometimes some of the systems can be forgotten about. So I know you're doing an assignment and you're thinking about things, but you may want to think about post-occupancy usage of the building and how you train your users of the building. So the most important people in this debate are the facilities managers. And some of you are working for facilities. So if you're looking at carbon reduction, it's how you use the building for the next 25 years or 30 years where you pay off the bill for building it, actually as opposed to the point of completion. So these things are changing all the time. So expect BREEAM to start looking at lifetime performance and how you monitor that. Okay? BREEAM is a scoring system which determins the performance of the building above, and this is where UK policy is, above building regulations control. So that's in the UK, this is the baseline, building regulations. If you look at our previous lecture on building regulations, you will see that we've had ongoing updating of the minimum legal criteria. So actually building regulations go to that zero carbon design. So if we expect building regulations 2016 to provide that, as I say, it's going to be something like 2018, 2019 when that final step comes in. So we're using the baseline performance to increase, but we've seen an appreciable increase in building performance over the last decade now with this very go-ahead, very strict minimum criteria. BREEAM rating level actually represents performance which is equivalent to the following classifications. So there's outstanding, which is currently about 1% of the top buildings are outstanding, but we have to increase that. Excellent is about 10% of our building stock. Very good is at 25%, good at 50%, and pass 75% building. So what we're trying to do is obviously push. Now, apart from building regulations stepping this up from good to very good over the last decade, many of the local authorities now use BREEAM as part of their planning procedure. So, for example, in city centres such as Manchester, London, Manchester or Leeds, Leeds City Council are now saying the minimum design standard you can go to is excellent. So you don't get planning permission for your office or for your hotel or for your school if it's not equal to excellent. So this is where we're tending to debate, looking at outstanding and excellent now for any new building design consideration. So everybody has to be an expert in BREEAM in order to get their building through it, okay? So that's how the other method of pushing design innovation. So the aims of BREEAM are to firstly mitigate life cycle impact of buildings on the environment. So it is about the lifetime performance. To enable the buildings to be recognised according to their environmental benefits, providing credible environmental label for buildings, and also to stimulate demand and create value for sustainable buildings. It was always considered that at one stage an environmentally friendly building or a sustainable building wouldn't have any demand. Why do that? You're paying extra money for something which doesn't count. BREEAM's been there to stimulate the demand, and in fact that's what it does now. So we're looking at the building products and the supply chain which fund or push the design of this. One of the considerations is that if you look at the very first case study or the very first exemplar of a public housing scheme, back 15 years ago we look at the BEDZ, the Beddington Housing Project. This was the exemplar. So basically they adopted passive housing, zero carbon and renewable energy for that housing development. And one of the problems for BEDZ project was that they couldn't actually get reliable boilers for the biomass feed. So this was a community energy project. They were using combined heat and power, and they were feeding the boilers with biomass. So it's very low carbon. The boilers all failed because the reliable supply wasn't able to be found. So in fact the workable boilers had to be brought in from Northern Europe, from Netherlands as I remember. So the British made ones didn't work. So you've got to have good manufacturers for these systems in order to meet these objectives. So it's taken some time in order to do that. But where do you find your high performance glazing? We had a debate about that actually in Hong Kong only last week. Where do you find these providers? And can you get that at a good price? We also now have a big demand in UK for high performance doors. The door's got to be as good a performer as the window. And when we look at these, they've got to seal, the frame's got to be there, but actually to get these low, high performance components, it's how the door fits to the wall. That is equally as important as the door itself and the window which is placed within it. So all these details now are so critical. So you've got to have the skilled trades to fit these things. So in domestic housing, our tradespeople will have no work unless they know how to fit doors, windows, put in services duct through the thermal insulation, how you put the MVHR unit into a building with the ducting and not penetrate the thermal insulation is important for us. You may be thinking, does that apply to Hong Kong? Yeah, it does, because at the moment we're generating a lot of cold air and you're just reversing the system. You need cold air to keep cool. You've got to keep it in the room. And so therefore, you've got the same technical issues as ourselves. You're just changing the heating concept. That's something that you may not actually resolve in this module. It may take a little bit more time to resolve the issue of subtropical and tropical climates from a low carbon point of view. So that is more study for you. It's just that we don't have enough time in these brief 12 weeks to pick it up. So when you're working for your project, think about the context. And so we can ask you to do so much. It's important that you know about this. You may not be able to solve all the problems in your assignment, but it's interesting. Okay, these are objectives of BREEAM. They're not mine, these are BREEAM's own objectives. I'll just quickly go through them, but market recognition of buildings. I think this is already with us in Hong Kong. A LEED or UK BEAM building or a BREEAM building have value. Okay? It's actually, where there's no limited regulation, clients now want these buildings because it's good for their profile, and we can talk about that. Ensure best environmental practices incorporated into the buildings is now very prevalent. It's a marketable commodity, people want it. Cost-effective performance is also key. People understand that by reducing energy bills reduces costs. So one of the drivers in the last few years for low carbon buildings hasn't necessarily been regulation, it's been reducing the cost of your energy bill. Because our energy bills are increasing rapidly. Despite the oil price dropping, electricity and gas are still very expensive. So we've got to try and reduce those bills. Customers don't understand the oil price issue. How come the price per barrel is low, but your energy price is still high? And that's obviously political, it's demand, but still trying to reduce your cost is important. We're still looking at innovation. There's challenges there, and if anybody's looked at renewables, you'll get to renewables later on, but the PV and solar thermal efficiency is a market innovation driver because they need to get more efficient. Awareness amongst owners, occupants, I think this is already there actually, but our big building owners, certainly from a UK point of view, the building owners such as British Land, okay, already have this on their agenda. The big chains like Walmart, the big supermarkets, all have objectives with low carbon buildings. It's seen as making sense for them, it's their profile, but they drive the market too. And they forced BREEAM to look at non-commercial buildings and make that more efficient. So ultimately it allows organisations to say, look, this is our credibility. So the corporate responsibility issue is driven by this. Okay, there are various BREEAM schemes which are available. BREEAM communities, okay, allow us to look at master planning. BREEAM new construction applies to new build domestic and non-domestic buildings. BREEAM in-use can be considered for in-use buildings. The issue is 99% of our buildings are already existing. We're only building 1% per year. Hong Kong has probably got a higher proportion of new buildings per year. It's a nice comparison. But in UK, we are actually in a bit of a mini boom. And London is driven by the same economics as Hong Kong. But it's only 1% of our building stock. So how we manage existing building stock is equally important. And there are some good examples of in-use buildings, refurbishments, which are through. from last year, BREEAM refurbishment domestic and non-domestic was put online. So there's a range of these schemes. You may say that BREEAM's trying to do everything. Well, it probably needs to, but from planning through to aftercare of buildings is part of their approach. The BREEAM offers standardisation. There are 2 EN ISO figures regarding requirements for certification. That is kind of logical now. So BREEAM come under BREEAM Global Limited, and that allows then for standardisation. So their assessors, their software, their acknowledgement and methodology is standardised. So that gives some credibility to the scheme. BREEAM New Construction is a good example of how we work through the standard as an example, therefore, of how this operates. So it's applied to new buildings. Its aim is to mitigate life cycle impact. It works with clients. You work with a client, a BREEAM assessor, and the certification process to evaluate the performance. It's quantified by a number of individual methods and criteria which goes across a range of environmental issues. What I'm going to do is try and take you through this bit by bit to show how it's applied. In terms of the planning process, there's guidance with the RIBA stages of plan of work. So, to give an idea about where this is brought in, these are the RIBA stages, stages 0 all the way through to 6 and 7. So this is normally how the buildings are designed, is developed under the RIBA plan. Alongside is UK government draft digital plan of work, which is BIM enabled, okay? And you can see that the BREEAM communities planning and BREEAM new construction are phased along these elements. So what is the moral of this story is that during pre-construction, during design, we are advised to make use of BREEAM new construction with the design phase. So approximately once you've gone through strategic definition, then in preparation and brief, concept design and develop design through to technical and construction, we're actually introducing pre-assessment and then into the actual design process of applying BREEAM. So in your project you may want to consider the evidence of introducing BREEAM from first principles. So it's not a bolt-on. It becomes more difficult when you bring it in later into the scheme. And often, once you get past strategic design, trying to then decarbon your building design becomes a bit of a disaster. So early intervention is the watchword. And I would say that from a number of our seminars and case studies run at the university, that's always the same thing, that you have early involvement provision. So watchword is to bring the team in right at the start to look at these concepts. So design stage assessment and interim BREEAM rating confirms the design performance can meet the requirements of the life cycle early on. It's called interim because it doesn't represent the building's final new construction performance. So we're moving from, when it's on paper, it's one thing. When it's actually put in place on site, it's another. Within the industry currently, when we look at the whole issue of building information modelling, any deviation is a bit of a bad thing. What we want to do is to get design certainty, so it actually leads to an as-built structure. So, by good planning, good detail, good simulation, hopefully what we do is go from there to there. In domestic, there's an appreciable difference in construction performance. So we have to try and limit it. If you compare UK construction performance to, say, Germany or Denmark, there's greater certainty that when you build the thing, it actually performs the way in which the designers intended. So I don't know how that works in Hong Kong, but the actual performance measures when you finally complete the building are obviously going to be important. So to help it, that's where the certification process works. So in order to complete an assessment, design must need to be at a point where the relevant design information is available to the assessor to make an evaluation. That's based on a scheme document which is then completed and reviewed. So getting through design stage is onerous. It means that the assessor is working alongside the design team, and there is an important part of ensuring design as any other member of that team, although they are independent assessors. What it means is that designs are verified, specifications in place, and you're actually certifying or proving the components you're going to use in the building are actually used on site. To finish off certification, we go into post-construction. And basically, post-construction assessment and the BREEAM rating confirms the as-built performance of the building. That final assessment is completed and certified after partial completion of the building works. There are two stages in that: a post-construction review, or PCR, of the interim design phase, and then a post-construction assessment. So this allows confirmation to be done, obviously. We should not underestimate just going through those processes and assessing that things are actually put in place. Again, there's a really good, a number of good case studies around which have shown how this is actually put through and can be achieved. The access to those case studies, I think we can manage. There are a few within the materials for the module. But some good examples which have really gone through detail, for example, include the Leeds Arena. This is a 32,000 indoor arena, a concert hall, but built to BREEAM excellent standards. And how that was achieved to meet design requirements was quite interesting. So it makes a good BIM case study as well as a good BREEAM case study. Another example, which we have a lot of detail on, is our own Rosebowl building, which is a 5-storey university building to BREEAM excellent. For multi-occupancy residential buildings, another university one is Carnegie Village, which provides something like 600 beds. So achieving a 600-bed student accommodation to BREEAM excellent is quite a hard feat. And in it actually are 2 passive house buildings. So those case studies are partially available. They were used as assignments actually for our students in this last semester. But they understood how these things were designed, put in place, and then the after use was of note. So you can see you need this system in order to try and get the design out, and often when the problems of performance are evident, that's a point of learning for the next project. Under BREEAM, there are various forms of construction which fall in. So these next few slides just categorise the different types. A lot of this is logical. We know commercial buildings and the division into offices, industrial and retail. There are a range of public housing sections which fall in, for example, education, but also then facility for healthcare, prisons, law courts. You may consider, is this working or has it come on? Is this all right?
Yeah, it's working.
It is working. Right. Okay, hopefully it is.
It's working? No, not working.
I didn't think.
No, it's not battery.
Is that what's happening? Okay, moving on back. There's another office, there's another classroom listening, so I can't elaborate. The classifications are useful. Think about the type of building you're using. Okay? You may wonder why these are there. We spend a lot of money on those buildings. So prisons also can comply to BREEAM because it's your electricity bill. And we're thinking about the value of these structures, so we spend a lot in that area. I just ran out of energy. Like that, I'll have to recharge it. Okay, good. Right, sorry. Sorry to the other classroom, we've got our coverage back in. As I was saying, the categories of buildings are of interest. If you're doing your assignment, think about where your category falls, because that's the type of the BREEAM product that you'll get. On this slide it is the public non-housing sections. Education and healthcare makes sense. But this is where UK puts a lot of its money, therefore its buildings have to comply. Again, legislation will cover not only housing but public buildings in particular. They are the exemplars. And over recent years, prisons and law courts have fallen in for just as much scrutiny because we spend a lot of money on them, we operate them, we have to pay the bills for them, the taxpayers' money is high. So actually we're seeing material benefits in reducing energy and increasing the efficiency. The previous slides that I spoke about getting pre-construction and post-construction design right, just to save money, applies particularly to these buildings. We've saved a lot of money by improving the actual design process, and that's where our BIM 2016 objectives come in, because we want to make sure these things come out the way we intended to design them. You can see multi-residential has its own sector, so that includes long stay. You can see the type of buildings which fall into multi-residential. Then there's a series of other sector, and they include hotels, hostels, etc., but also non-residential institutions such as art galleries. Some of our students back in the UK have been working on museums and art galleries recently, and they also must apply. And there are particular structures, also assemblies, cinemas. I mentioned one earlier in this lecture regarding the Leeds Arena, and into other including transportation hubs. So all of these things should comply, and they just need the tool, the product, allowing us to do that. So that's where the BREEAM aspects come in. Under BREEAM 2014, you can see the various sections which make up BREEAM, and then I'll just run through them. The different sections: management, health and well-being, energy, transportation, water, materials, waste, land use and ecology, and pollution. And you'll see that in each section there are a number of credits available, so they vary somewhat. The weightings are provided as running down, so you can see that energy is 15% of the available credits for your BREEAM rating, but there are as many in other areas. Now the asterisk shows a change over previous versions of BREEAM. So if we're looking at slightly older notes, the figures have changed a little bit for 2014. This is always a problem when dealing with this module. Things are updating all the time. But interesting, isn't it, where you can score your points on management, health and well-being. But also, I get a few of you just to think about water, think about wastage, land use and ecology and pollution. There's enough points there to take a baseline entry building to not just excellent but outstanding. So when you look at maximum points in these areas, you can really move your building. And whilst there are minimum standards applied to each of these areas, working on a few of these aspects to really develop can change things. So thinking about the university lecture, which will be available on Twitter and online actually on Wednesday, and recordings are available already actually online for previous lectures. That water one might be of interest to you because it's as an important commodity as anything else. A few notes just to pull up. Minimum standards are set for each section, and additional credits are awarded for innovation. We'll talk about that shortly. These pop up as I click. In terms of management, credits are awarded for planning, design meetings, on-site control and user information. And for your assignment submission, if you were to explain a reasonable policy that meets this and the requirement, that's what we'd be looking for you in your submission. So if you wanted to score maximum points for management, think about the things I mentioned before. Early involvement of the design team, ongoing electronic communications. You might be using video conferencing to do that. You may move to a BIM-based solution straight away, and this is how you can start to look at that. User information, how you pass on that information. That's quite an easy set of 12 marks to achieve. Let's just move down this list. For energy, and I'm going to do this in a bit more detail, credits awarded for your CO2 emissions reduction, controls, for example, such as submetering, lighting, low and zero carbon technologies, actually applying that to the white goods. So that is your washing machines, those sorts of elements in your building. That also achieves your credit. Combined heat and power and drying spaces. Drying space is so important to Hong Kong, isn't it? You might go to the laundry, but it's important to have drying spaces. Again, to control energy in low carbon buildings. Okay, noting those scores, they fall into benchmarks. So we've been talking about the BREEAM descriptors for outstanding, excellent, very good. You can see the percentage scores that you need to equal or beat in order to achieve that. Obviously, thinking about the steps from good or very good to outstanding, match that with your points, and then obviously this is how we're going. The advantage of the rating system is that it's easy to understand. The detail is in the credit. So we're going to look at these categories. So we can see that management is split up into a range of credits which are available for different categories. So we can just running through these. Project brief and design relating to consultation, appointing a sustainability champion. 4 credits can be in there. So actually, at AIBE, we did have a lecture. One of my colleagues came to Hong Kong about 4 weeks ago, Lindsay Smales. He gave a lecture to the housing students, but he should have given a lecture to you, because he's an expert in stakeholder consultation as well. In fact, a lot of things he was talking about get you points elsewhere in your BREEAM assessment. He was even talking about, he spoke about growing your own food. But it's quite a big deal in some buildings, actually. And in the biodiversity aspects, that's where all of that starts to crop up. Anyway, life cycle cost and service life planning. So if you go into cost analysis, you can see the credits available. Just to highlight these responsible construction practices. When I was in housing, I was previously, before I came to Leeds, Beckett, Leeds Met, I was involved in housing. We really pushed responsible construction practices. So we made it mandatory for all of our contractors to have ISO 14001, that there was a sustainability champion, that everybody was a considerate constructor, and that the site impacts were monitored. So as a funding organisation working for housing, basically organising housing associations, we really pushed this one. We thought it was good for our residents. Commissioning and handover, you can see that there are some credits available for handover schedule, commissioning the building services, and commissioning the building fabric and handover. So paying attention to that gets you points, if that's useful. The guide provides some good, useful approaches to how you achieve these things. There's a bit more detail in that. But again, try to think about what these mean and how you can approach it. Health and Wellbeing has a range of credits awarded. Where it relates to building services is in visual comfort. You can save money on getting the right daylighting factors in your building. That makes it more passive. If you're able to pick up on daylighting, glare control, you're actually picking up points for BREEAM as well. Indoor air quality is quite a big deal. So you can see there's a big chunk there on minimising sources of air pollution at 4%, 4 points rather. If you've got laboratories, it can be assessed. Thermal comfort also comes in here in terms of achieving thermal modelling. So undertaking modelling actually allows you to get one of these 3 credits. Adaptability and climate change projection also is there, as well as thermal zoning. Thermal zoning is the clue to non-domestic. So where you don't worry about heating your corridors but focus on rooms is one of those control approaches. Acoustics and safety and security also play a role in this. The most important category we traditionally think is of energy. And you can see that there is up to 12 credits available for looking at energy performance. The energy performance rating, EPR, is a technique in itself. It's another tool, and actually it's our approach now to measuring the actual energy per square metre within the building. I've got a few slides to deal with this a little bit later on, even though that time is running out. Going to carbon negative brings in a large number of points. So you may want to think about what carbon negative is, but there are some good examples on the Science Park here in Hong Kong about actually going to a carbon negative building. So what we're talking about is that we're not just thinking about minimising carbon, but if you get a passive building which has no carbon output, then using renewable energy resources, which then contribute back to the grid, is a carbon negative action. Okay? So the buildings actually make their environment better. And you can do that with water too. Having a strategy where you bring in water, but you clean your water. And so you're putting clean water back into the environment is a very good thing. So that's what Wednesday's about. So carbon negative buildings, energy monitoring, lighting control, low carbon design. You can see this passive structure. A passive design approach wins you some degree of innovation. So passive cooling, ventilation systems is a different thought about a building, but achieves background. As we work through storage, also on transportation, we can score. Examples could be on lifts, escalators, etc. Putting systems into standby or power down mode. Regenerative drives also wins points within the internal building transportation. You may think of some case studies about how that can be used, because that's quite common. Some focus on laboratories, some focus here on drives, consuming loads for white goods, so washing machines, dryers. A good example in Hong Kong which you could visit is the Mayho House in Sun Shai Po, if you know it. It's the YMCA. Do you know that building? Go to Sun Shai Po, visit the YHA at this Mayo House. It's a Hong Kong heritage centre, but also in the YMCA they have, Youth Hostels Association building, so it's the YHA. They have some examples of these white goods. It's the laundry and the dryers which they use, the washing machines and dryers. They're examples of that 2-credit approach. So it's a visitor centre, so use it, visit it. So there are good examples with drying space. So there's some good examples in Hong Kong if you look for them. Some people are doing this. We just all have to do it and then we change it. So what is exemplary now becomes the norm in 5 or 10 years' time. You can see that we look at transportation. It's okay, Hong Kong has got some fantastic public transportation. So I think if you can design your building around that, that becomes a very positive aspect. This is in a UK context, so I think some of these things you may look, but certainly look at this area, the accessibility index, the walkability to MTR or to a bus station, okay, is quite useful. If we're off campus or if we're out of town, it becomes a bigger problem. Amenities. This also comes in for assessment. So, can you go to a food outlet? Can you do your shopping? How close is it to those amenities? Okay. Cycling facilities, 3 credits for storage, showers, lockers. I've given previously a presentation to the HKIE here in Hong Kong, but I based it on a multi-residential building, which, sorry about that, I thought sorry about that. It actually has a facility as apartments for cycle storage and drying space. This is the negative. This is what I don't understand, car parking. That's what I put the exclamation marks in. Why they should encourage this on the BREEAM is a bit strange. And a travel plan.
Limitations of the car park, number of car parks.
If you read it negatively, yeah, the opposite way around, yeah. So minimise it, control it.
Minimize it.
Yeah.
Reduce the division of car parks.
So you provide some but not a lot. Yeah. And then what you do is then provide a travel plan. Our university has a travel plan. So we might say who can share the travel. So how do you advise people to get there from A to B? And if you're on business, what's the travel plan? So if you're the boss, do you use your own car? Or can you use a taxi? Or can you use a shared car facility? There are various schemes available. You might use an electric car to chauffeur your chief executive to a meeting. This is the water consumption. There is a BREEAM calculator which you can option. So you get points for using the calculator, essentially. Also measuring the water consumption, efficiency of your installation is an easy one to do. But also the other one is to use grey. Do you all know what grey water is? So rainwater, you collect it. You can use it for toilet flushing and for options like this. Again, we use grey water collection at the university for its halls of residence. We don't have to, normally it's a tank which is located at the side of the building somewhere, and then that's recirculated and used. Water monitoring, so if you start to meter your water, you tend to reduce how much is used. Water leak detection, so no systems are losing water. We lose a lot of water that way. And also the water efficient equipment, particularly again on your white goods, can be utilised. Really working through quickly on the materials. You can see, now this is quite useful and you'll be able to access this online for free, the Green Guide to specification. All you need to do is register. So if you go to BREEAM, you'll find that they have a ready-made directory of materials online which have their environmental impact already assessed. So it's a little bit complicated because you look at ratings which add up to points which then give you credits. So it's quite a few processes. You might find that time-consuming and convoluted for your assignments. I would say make reference to the Green Guide and make some examples. And in fact, if you base all your materials off the Green Guide, you're going to do very well. So an assessor would help you with that. But it is, you do a lot of work to get the credits. That's the thing. Information actually comes into the European Products Directive, which was mentioned a few weeks ago. Utilising that also helps you. So when you focus on your policy for using materials is that they do comply and they are assessed. Also, components and materials figure into it. This is becoming easier now with materials taken from our national database. We have a new electronic database of materials which we bring into our bin information. So the AIBE, through National Building Specification, or NBS, have an online catalogue. A lot of materials suppliers say, we want to be on that catalogue, and that means that their information has to be codified to fit into the COBE Excel spreadsheet. So that's driving a virtual marketplace for this material. Boundary protection, landscaping, there is a very specific requirement on that. responsible sourcing of materials. Basically all timber that we now use is FSC accredited, so it meets the Sustainable Forestry Council's guidance on access. Also, you can have a sustainable procurement plan for your materials, which also, just by writing the plan out, gives you a credit. So that's another aspect to focus in on. As well as local. Responsible sourcing is obtaining your materials from local sources to minimise transportation, reputable producers, people that don't put waste into their environment. If you do a bit of research and you know the Living Building Challenge, you might find there's a bit of innovation there in this list. You can go over and beyond the Green Guide quite easily if you look at that. So I'll give you a few hints of where innovation could be made. You can see that this continues with more credits for insulation, designing for durability. A lot of aspects here about, this is how materials avoid degradation from environmental agents. So the longer they live, the better they are, because they've got more longevity. So you might be thinking about a building here in Hong Kong, how it's painted, what sort of external elements are being used, because they're under an increased amount of UV radiation, temperature extreme, rainwater penetration here. So how we avoid that? Maybe you're looking at the cladding to the building. How can you avoid these, all these forms of material deterioration? And obviously, material efficiency, avoiding waste. One of the things you can go for is a zero waste approach. It's interesting to just consider how much waste buildings produce. Adopting zero waste is very useful. So a UK site today will not accept any waste materials. So suppliers bring the materials on the pallet and they take the pallet away. If the materials are shrink wrapped, the polythene is taken back by the supplier. The cardboard is taken back by the supplier. So there are no fires on the site. The skips really have recycled materials in them. They don't actually have waste to landfill. So our landfill taxes are very high in the UK. So we don't put anything in the ground anymore. We recycle the materials. BREEAM has helped us do that because you can actually pre-cut your materials to go into the building. So you know our roofing materials, they're all pre-formed. So you can have quite complex shapes, but they're pre-formed by the computer-aided design, therefore you reduce your wastage. This is our wastage section. You can see you can have a management plan, 4 credits for just doing that, making use of recycled aggregates, minimising your operational waste and labelling and compacting and composting. Also in terms of your floor and ceiling specifications, those are, can be controlled just by going to the correct spec. Furthermore, recognising measures which mitigate impact of extreme weather conditions on the site. Functional adaptability is useful, future changes of the building over its lifespan. So how flexible can you make the building? So will it have an afterlife? So for example, how we put the computer, going to wireless is very easy now, but making the building adaptable so it minimises the building cost when you come to reuse it. So can you put a component in which you can unplug and recycle when you come to update some of the internal systems? And that's what these sections all relate to effectively. This is an overlooked aspect, land use and ecology, ranging from site selection, enhancing the site, and long-term impact and biodiversity. So the kind of systems which we are using to put this in action are water collection, drainage. Sustainable urban drainage is a big thing. We now flood a lot in the UK. You have high rainfall events. Where do you put the excess rainwater in a safe manner? But also some methods about wastewater treatment, sewage treatment, and doing that in a sustainable method. And some methods, you need a lot of land to do that, but actually these can be ways of using natural vegetation to filter water and obviously minimise the impact on existing overburdened facilities. Pollution control, you can see that refrigerants was a big deal for cooling, actually. So basically, you could go to zero refrigerant buildings, which has a big impact on your credits. Limiting your nitrous oxide emissions, surface water runoffs control, reduction of nighttime light pollution, etc., and noise pollution are the factors on pollution control. And then finally, there's an extra 10 credits on innovation. So basically, you can look on various BREEAM factors and develop them as research projects to get innovation credits. So this is what it's about, that the project has a certain technology which is going to develop and enhance. It may be a lighting control system, it may be a new method in cooling, it could be improving efficiency of your building component, whatever it is. The areas of innovation which are allowed are in these following categories: from construction practices, aftercare, visual control, air quality, reduction of energy use, water consumption, life cycle. Reach BREEAM, achieve BREEAM, these credits do have to be met. So for very good, you can see excellent and outstanding, there are criteria which break in over and above the requirements. So in order to get on the Richter scale, there are some essentials. These are the essentials that you must have. So if you work through, there are credits which you need to score in order to get to excellent and outstanding in, for example, reduction of energy use. So these are the must-haves in order to get through. So don't forget that. If you lodge something in one particular area, forget about these mandatory requirements. So you must score at least 1 credit to get excellent BREEAM for water consumption. You can go for outstanding, you need at least 2, and so forth. Okay? These slides are different, Alan, but they relate to energy performance ratio. So that energy performance criteria is achieved through the EPR. This is new approach. There is an online calculator. The moral of the story, I think, is to follow through this procedure when you're calculating. In order to use the EPR, it's another piece of software. You could use the SBEM, which is very similar, but this is merging the energy demand from the building, the carbon that's used to generate power to the building, the type of energy you use, and then minimising the CO2 outputs from the building. So basically it's 3 components: primary energy, energy demand, and CO2 emissions. And you get an overall weighted score from those factors based on the overall size of the building. So those are those 3 factors: energy demand, 25%, energy consumption, 41%, and then CO2 emissions, 34%. So in terms of maximising your EPR, getting the best from that, these are the factors: building fabric, the building services, and the fuel source which you then select, which is a key thing. I've done over an hour.
Okay.
Was that useful?
The technical software